Hey, good afternoon, guys. Just wanted to make a quick video explaining the solutions to the free response problem that I had you do for homework. And this was not a direct copy of the problem I did on the first video, but it was really similar. It had its own unique pieces to it. And so I want to go over those just a little bit more. But I also wanted to definitely let you have the answers and then also just maybe a little bit more of an explanation as to how to get through some of this. Okay. So I'm going to jump right into it as to make the video not too long. So same idea. We've got this graph of f. I know that g of x is defined as this accumulation function. All right. And so we're working with the same idea that g prime of x is equal to just f of x, or this graph itself. All right. Again, I don't know what g of x looks like, but I know that g prime of x is equal to f of x. And so I can get a lot of information from just this graph. All right, so let's jump in. Part A, does G have a relative minimum, a relative max, or neither at 10? Justify your answer. So we have to look at right here, x equals 10. Well, I know that in order for a function to have a relative maximum, it needs to be increasing and then decreasing. A relative minimum needs to then decrease and then increase. Or in other words, its derivative needs to be positive, then negative, or negative and then positive. Well, in order for that to happen, g prime of x, which equals f of x, would need to go from either below the x-axis to above or above the x-axis to below. So if I'm looking specifically at x equals 10, pretty clear that that does not happen. Right, so the graph of f just stays negative, right? So you hit 10, and then immediately after it just keeps going down, and so therefore the function g has neither a relative max nor a relative min at x equals 10. And you can say that because g prime of x, which equals f of x, does not change signs, or you can say that it's negative for this whole region. Both of those work. This is just a sort of a sample justification, and so all of that works. Okay. All right, move on to part B. So this one was, does the graph of G have a point of inflection in x equals 4? So these first two are really nice because it specifically tells you where to look, and we can gain a lot just from that. So if I'm looking at x equals 4, all right, so right around here, I'm trying to figure out, does G have a point of inflection? Well, I know that points of inflection occur when the second derivative of G, right, so G double prime, which in our case we know is equal to f prime of x, that has to switch signs, right? So it has to go from either negative to positive or positive to negative. And so now, since I'm looking at f prime, which is the slope of this graph here, I want to see that, well, does that change at this point? And yes, it does, right? So I'm increasing, which means my derivative is positive, and then I start decreasing, which means my derivative, or f prime of x, is negative. And so at x equals 4, g double prime of x changes signs. Therefore, there is a point of inflection. All right, you can see that graph of g has point of inflection equals 4, since g prime of x increasing for this interval and then decreasing, right? Or in other words, it changes signs at x equals 4. Apologies if you hear that dog barking in the background. Not much I can do there. All right, move on to part C. Find the absolute minimum value and the absolute maximum value of G on the interval. So this one's a little bit different. It definitely has similarities to things that we've done. All right, but it's definitely a little bit different because I'm talking about absolute min and absolute max. I'm actually finding the value of those. All right, so I'm actually going to jump just down to sort of your piece here, just so you can see how this is set up, because you have to consider a couple of different things. The first thing you need to consider is, well, where are all the spots where there could be an absolute min or an absolute max, or even just a relative min and a relative max, right? And again, we talked about, well, what needs to happen is the derivative, which is f, needs to change signs. So where does it change signs? Well, it crosses the x-axis at x equals -2, and it crosses the x-axis at x equals +6. So those are the first two spots that really jump out as, being a potential minimum value from negative to positive and a maximum value, right? So the graph of f is going from positive to negative. In other words, G is decreasing and then increasing, and then increasing and then decreasing, right? So those are my two candidates for relative maximums, which could be an absolute max or min. And then the other thing I have to make sure of, I'm going to come down to this chart right down here, For absolute, remember this, right? We talked about this, we stressed this when we did this, you have to check your endpoints. So what's happening at -4 and what's happening at 12. Okay, so here are all of my candidates in order for an absolute min and an absolute max. Now, what we have to do is not just point out, well, this is where the x values they could happen. They're actually asking for the outputs, right? What is the absolute minimum? What is the absolute maximum? And so I have to take each one of these x values, -4, -2, +6, and +12, and plug them into this function, right? Plug them into this accumulation function. And so in so doing, if I just look at -4, right, what this is saying is I want to take the integral from +2 to -4 of f, right? And so if I look at that coming up here on the actual graph itself, I have to go from 2 all the way to -4, and I'm actually going to collect that area. So you have to do some area computation here, which means you're going to have to find the area of this triangle, right? And then also the area of this triangle. Now, what we want to be careful of is two things, and I'm not going to do each one of these. I'm just going to explain -4, and then you can kind of use that as a model for -2, 6, and 12. So if I start at 2 and go to -4, I'm kind of going backwards, right? Which means I'm going to have the opposite type of area that you normally would think of. So the area from 2 to -2, while it's above the x-axis, since I'm starting at 2 and going to -2, going backwards, this is actually considered negative itself. All right, so this is negative area going from 2 to -2. And then the area underneath the x-axis from -2 to -4 is actually positive, right? So this is positive area if I'm traveling backwards. So what's the area of this triangle from 2 to -2? The base itself is 4. And so 1/2 my base times my height. Well, my base is 4, my height is 4, so that's 16 divided by 2 is 8, right? But if I'm going backwards, this area is -8, just this triangle right here. This is -8. And then I'll add the area here, which although it's below, since I'm going backwards, is actually positive, right? And so this base is just 2, but its height is still 4. And so 1/2 of that is 4 times 2 is 8, divided by 2 is 4. So I'll have a -8 plus a +4, which equals -4. And that's where you get this -4 right down here. Okay, so that's where this -4 comes from. So you would have to do that for each one of your x values, each one of these candidates. And you just have to keep doing the area over, right? So we actually already did from 2 to -2. We already found that, which is -8. So we kind of already talked about that one. But then, so as soon as you do -4, -2, 6 and 12 is sort of business as usual. So the area from 6 to 12, I'm sorry, from 2 to 6, apologies. The area from 2 to 6 is going to follow that same rule. Anything above the x-axis is positive. Anything below is negative because I'm moving to the right, right? I'm moving forward. So the area from 2 to 6 is just this triangle right here, which is identical to this triangle. And so this is actually a +8 area here. And that's where you see that +8. And then if you go to 12, we can see what happens where, well, actually this area plus this area, since this are the exact same triangles, these are identical, they cancel each other out. And so I just need to really consider the area of this triangle right here. And that ends up being -4, just like this one over here. So that's where you get those values from. Once you find all of them, then really it's just about picking out the highest output and the lowest output. So I see that the highest output is +8, and that happens at 6. And then the lowest output is -8, which happens at -2. And so considering your candidates, -2 and 6, considering -4 and 12, these are all points that you have to add in order to get a perfect score here, right? So candidates, endpoints, and then your answer, which I'll scroll down just a little bit here. We can see absolute minimum, g of -2 equals -8, absolute maximum, g of 6 equals 8. All right, so you're good to go right there. Okay, last one. It threw most people for a loop, or at least just talking to them. It was the one that gave them the most difficulty. And so it says for -4 to 12, find all intervals for which g of x is less than or equal to 0. You have to be really careful with this one, right? And you have to really understand what it's asking you, which is not I think, clear and obvious right off the bat. So the first thing that it's asking, well, really the only thing it's asking is if g of x is less than 0, and if g of x is defined as an integral of this function, or really the area underneath of the curve of f, in order for g of x to be negative or equal to 0, but let's just focus on the negative part right now, the net area of your interval from 2 to whatever number you're choosing needs to be negative. And that means that the net area or the majority area needs to be below the x-axis. Or if we're traveling backwards, so from 2 to the left, the net area needs to be above the x-axis. Why does that happen? Well, that's because when you travel from a lower number, right, we've talked about this already, to a higher number, or sorry, from a higher number to a lower number, I really can negate the whole integral and flip the bounds. All right. And so in order for this to be negative, I need the majority of the area to be above the x-axis, which is like what you would normally consider positive, but then I'm going to make it negative, right? So if the majority was below, this would be negative, and then I multiply it by negative, and then that would be a positive, right? So we have to be really careful there. And so where are all the spots that happens? All right, we have to come up with basically every x value that I can plug in to my initial accumulation function that would cause a negative area. And so really all we're doing is picking stopping points for the integral that cause a negative area. So I want to start with the easy one, which is, notice that this says it's also equal to 0. And so the easiest one that you can think of is, I know that any integral starting from a number and then going to itself is 0. So at x equals 2 is definitely going to be part of the answer, right? Because the integral from 2 to 2 is 0. And so that's definitely at least one answer, which is x equals 2. All right, but I know I have to start at 2. So let's just sort of analyze the situation. And I'm going to go to the right first, just because that's a little bit easier and we're used to doing that more. So if I start at 2 and I move forward, what are all the x values that I can stop at where the net area would be negative? So from 2 to 4, well, that triangle is above the x-axis, which would be positive, so that's no good. From 2 to 6, this whole triangle is above the x-axis, so that's positive, so that's no good. So let's keep moving forward. Let's go from 2 to 8. Well, I know I collected all of this triangle, right? So I've got this triangle. And then from 2 to 8, I've now collected also this triangle, right? And so this smaller triangle is actually only half of this larger triangle. And so the net or the majority area is still positive from 2 to 8. So 8's not going to work. Move forward to 10. Right? So from 2 to 10, what happens? Well, now I've collected both this big triangle and this big triangle. And since they're identical, which we talked about already, the majority area or the net area is 0. It's the exact same on above the x-axis as below the x-axis. So that actually works. So right now I've actually got 2, which worked. So x equals 2. And then also x equals 10. So I know that if I went from 2 to 10 on this integral, the area would be 0, which is good. All right, so 10 is definitely an answer. Then if I keep moving forward from 10, so let's say if you did like 11 or 10 and a half or 11 and a half all the way to 12, I would have already canceled out this top area with this bottom area, and now I'm just collecting all negative area from 10 on. So actually any x value from 10, including 10, all the way to 12, including 12, would work. Okay, so from right now we have 10 to 12, including 10 to 12, and then also x equals 2 itself. Okay, so x equals 2 would work. All right, now let's consider the case of what happens if we were to move to the left starting at 2 instead of to the right. Well, if I move to the left, again, I just talked about, well, now I have to sort of rethink my area, which is anything above the x-axis is going to be negative and anything below the x-axis is going to be positive because I'm going backwards. So the area from 2 all the way to negative 2 is above the x-axis. And so all of that area would be negative. So that's all good to go for us. All right. So anything in between 2 and -2 would work. And then if I move from -2 to -4, this smaller triangle isn't big enough. Sorry, this pad's not working. There we go. This smaller triangle isn't big enough to make the whole integral positive, right? So even if I went from 2 all the way to -4, this larger triangle would be negative, this smaller triangle would be positive, and therefore the net area would still be negative. So anything from 2 to -4 would work. Anything from 10 to 12 would work. And so I've got my answer there, right? I've got my full intervals that I could work with. And so I'll scroll down to the answer, and we can see, right, anything from -4 to 2, and then from 10 to 12. And really the only answer is, like, you kind of did a lot of thinking and work there. The answers are your intervals. Okay. I hope this was helpful. I'll post this solution on my Malvern just for you to look at. Of course, you can use this video and pause it, though. Let me know if you have any questions. Okay.